Okay, before the break we had talked about adjust this and adjust that, and twice someone said how. So let's cover how. Understand that the how on the 4X is push buttons. On the 3X, we have one 3X that will be adjustable with an ammo box. We have 3 vehicles we're retrofitting. That means one group is going to be the fortunate ones that get the special optimizer with the ammo box tuning capability. The other 2 groups are going to be doing it the hard way. So I'm going to cover the hard way. Again, if you have ammo box capability, how do you tune it? Push buttons. So let's start out with the coolant sensor. We're actually going to cover tuning the fuel cell probably tomorrow, because I doubt any of you are going to have your retrofit done this afternoon and ready to tune the fuel cell. So the coolant sensor. We have our optimizer, and then we have our coolant sensor. I'm going to draw this up this way, where the one wire goes to ground. Tuning this requires a scan gauge. If you have an older Ford or you have an older import that does not have data stream information, you're going to have to get a chart like the one that was handed out that shows you what the temperatures are for the different resistance values across the sensor. To test resistance, you would take your ohm meter and simply back probe this wire, back probe this wire, and then go to your gauge. With the optimizer, yeah. I'm sorry, let me draw this out right. Sure. Can I screw something else up to help you out too? All right. With the optimizer in the circuit, it will change the resistance value between these 2 points.
I need you to swing your board just a little bit.
Hey, my board ain't no swinger.
Much better, thank you.
So with the optimizer in the circuit, our resistance value will change. With the optimizer in the circuit, our temperature readings on our scan tool will change. Now, let's assume that we hook up the optimizer, we get it up to operating temperature, and our temperature is lower than what we want. At that point, that's all the more you're going to get on a manual adjustment. If it's lower than what you want on a 4X or this 3X, you can adjust it with the ammo box. But on these early 3Xs, you cannot adjust it higher. But let's assume that your scan gauge says the coolant sensor is reading 238 degrees. Too high. We want to bring our temperature reading down to like 215 or 220. So the way we do that is we go in, cut the lead coming out of the optimizer, and then we add a resistor. By adding a resistor here, we've increased the total resistance across the sensor. Increasing the resistance will show the computer a lower engine temp. By putting a resistor here, we've increased the total resistance across the sensor as far as what the computer can see. And that additional resistance across the sensor will show the computer a lower engine temperature. So we go 238 degrees. Let's assume we put a 100 ohm resistor in here. It takes it from 238 to 234. We need a bigger one. So then we put a 1,000 ohm, a 1K ohm resistor in here. And it gets us down, say, 222. Well, then we might put a 1.5K ohm in there, and it gets us right in on where we want to be. You could also put a potentiometer in there and just turn the knob until you get the temp readings that you want on your scan gauge. So on the early 3Xs, we cannot raise our temperature reading on our sensors, but we can lower it. We lower it by manually splicing in additional resistance into the optimizer's signal wire that splices into the ECU's signal wire. Yes, sir?
If we use a potentiometer, what range would you suggest that we could use for that?
It's going to vary from vehicle to vehicle. We've had some in here and it took 100 ohms, 200 ohms, and that was all the trim that we needed. We've had some where we were adding 6 and 7K ohms to get the reading where we wanted it. Yes?
I put 15K on mine.
And it was a Ford product, right?
Correct.
With the newer, you pull this off, slide it over, set it to the Ford, and it would have been a whole heck of a lot less. Might have been 1.2K or something, maybe 2K. So, looking at your scan gauge, or if it's an older vehicle that doesn't have data stream, looking at your own meter with your chart in front of you, this is how you're going to bring the temperatures down into range again. What we tried to do was set the optimizer so that the temperature would be on the high side. Now there's the digital pot. One of these 4 little black things here is the digital pot that controls what the scan gauge reading's going to be because of this circuit. And the digital pot is adjustable by changing the readings in here. The readings in here are changeable through the ammo box. So if you have an older optimizer,
Which has a legend right there. That's the legend.
coolant sensors number 1, air temps number 2, and O2 sensor is number 3. Beautiful.
All right. Said there's a small minor glitch in the software, but he wanted us to have it, and he said it should be functional. He sent it the way it was hooked up so that we would see how to hook it up.
Okay,
So it was all hooked up that way. That's it.
great.
All right.
Awesome.
We get there. It's just little pieces.
Did I finish my thought?
No.
No.
Where was I?
Adding resistance to get what we wanted.
Okay. So let me rephrase this.
Can't you?
Ask me a question so that I can pick up where I left off. What did I answer?
Moving the thing over for the Ford to bring it
Adding
down.
resistance
Oh.
is from Art's question.
Yeah. So if you just take an optimizer, put it on a Ford, and it's set for normal, I mean, you're going to peg it at 253. Most of the Fords that we've done this on, you turn the key on, and both your air and coolant temp reads 253 degrees Fahrenheit. So you just pull this off, slide it over to the Ford, and now you should be in a range where a reasonable amount of resistance will get you where you want to be on those 2 circuits. Because 15K is just way too much. But,
Now, if he only needed to change the coolant and not the IAT, then he could cut the jumper.
I'm not 100% positive that jumper is for the coolant. It could be for the air temp. I don't remember anymore.
Is there a way to find that out?
Okay, so that affects the air temp. So you cut the jumper, and you've just given the air temp Ford values, but the coolant temp sensor will still be normal. Thank you. Thank you. The same is done with the air temp sensor. If your readings are too high. So now for timing, putting a pot in there might be really good because then you can just turn a knob to adjust your ignition timing, huh? Which, by the way, was an idea for a product that I had for outside of this for the performance guys, but nevertheless. So you know how to get your scan gauge readings where you want it by adding resistance values in there. I see a puzzled, quizzical look on your face.
I'm just trying to double check your logic.
Okay. Let me draw this up a different way. We got our sensor. One wire goes to ground, the other wire goes to the ECU. This is a resistor. The resistance changes by temperature. It's called a thermistor. If we want to change the total resistance, there's two ways of doing it. One is to put a resistor between the two. Remember yesterday when I drew out a parallel circuit versus a series circuit? Okay. A parallel circuit is going to provide two paths to ground. So we are going to lower the total resistance of that sensor by putting a resistor in parallel. We are going to lower the resistance. What we're doing here is we have one path to ground this way, and then we're going to have another path to ground this way. Adding the optimizer into the circuit is like adding a resistance value in parallel.
You drew that line wrong. You want to go from the ground to the ECU through the optimizer, not to the sensor. You want from ground to ground.
Can't hear it.
Yeah. Wait,
No. That one's right. You want the ground from the optimizer to the ECU.
We can't hear it.
You went to the other ground from the optimizer. There you go.
So by adding resistance here, we're providing an alternative path across that sensor. The more resistance we add here, the less additional voltage we're going to bleed off, the less effect we have. If we put a 1 meg ohm resistor here, we've changed the circuit so little that it won't even show up on the scan gauge. We put a 1K ohm resistor here, and we've made a dramatic change to the circuit. We put a short jumper lead that's like just 1 ohm, and we practically shorted it out. You see the trend there? Yes, sir?
Couldn't you put another parallel circuit with a resistor in it to raise the temperature reading?
Showing them how to
Yeah, but you, yeah. Good point. You know, I'm thinking this through as we do this, and you know, you probably could.
You have to put it in series.
No, because what you'd have to do is you'd have to be able to reduce this resistance. And as it stands, the minimum resistance is already established by the optimizer. We can take and raise this resistance, but the lowest value is established by the digital pot in the optimizer. So we couldn't do that. Now, if we were to try to create an additional path across, then we lose our timeout circuit. And that resistance value is going to be what affects the temperature reading in the ECU when it's stone cold, warmed up, or whatever. I knew there was, I thought that through, and I knew I came up with dead end.
Now, if you hit, if you're on a regular car,
As opposed to what?
that's to a Ford,
Okay,
okay? And you can't get, and your reading's not high enough, if you move that over to Ford,
that's going to go way lower
it'll drop it
because the
down.
higher resistance values will affect the circuit less.
So it'll drop it.
Right.
Okay, so it won't raise it.
So if your normal operating temperature, say 195 on the coolant circuit, you have it on a normal car with the plug in the normal position, and it only gives you 212, and you'd like to get it up to like 215 or 216, you take it at 195 actual temperature, shift it over to the Ford, it may say 196 or 197 at that point, instead of even the 212 that you got on the normal setting. Yes, sir.
I think the confusing part here is that by adding resistance on the optimizer, you are actually lowering the circuit resistance to ground. You're not raising.
No, you're increasing it.
No, it's in parallel.
Instead of repeating the question, I'm just going to draw something else out. So we have sensor, and then we have ECU that goes basically here. And then we've got the optimizer that's going to go from here to ground, with the optimizer essentially being an additional resistor. So we have the original sensor resistance value, plus then we're going to come up and we're going to add a parallel circuit of resistance through the optimizer, which lowers it. So if our temperature readings are too high because our resistance value is too low, then what we want to do is we want to like go in here and splice in yet another resistor, because by adding resistance in series,
That's in parallel though.
this is, okay, this resistor here is in parallel with this resistor here. But this resistor here is in series with this resistor here. And by adding this resistor here, we are adding more in series. So the total amount that we're bleeding off around the sensor in the parallel circuit, we're bleeding off less. The more resistance we add here, the less we're bypassing the sensor with. Like I said, if I went to a 1 meg ohm resistance value, whether it's through the optimizer only, through the optimizer plus additional resistance, if my total resistance here in series is 1 meg, we essentially have altered the signal in no way. So as the resistance value goes down, then the temperature reading goes up. We take it too far. Now, this resistance circuit here in parallel is bleeding too much voltage off. So in our parallel circuit, we've got too much voltage draining off the ground. So we need to take what we can affect, which is just our side, the optimizer side, and we need to do higher resistance there so we bleed off less in our parallel circuit, which is what we're going to do right here. We're going to add additional resistance in series, additional resistance to our optimizer's resistance. So we take the optimizer resistance and then add to it this additional resistance in series for our parallel circuit. Gosh, this is getting confusing. I am so sorry. I don't know a better way to explain it other than if you add resistance here, your temperature readings go down. If it doesn't make sense to you, get a basic electronics book, because I can't explain it any other way. Add resistance, the more you add, the lower your temperature reading on your scan gauge. So now, we hypothetically have a retrofitted vehicle, and we've gone and we've adjusted the electrolyte concentration. We have 15 amps coming off of our fuel cell. We have our scan gauge out. Engine's up to operating temperature. We've got our range on our coolant temp sensor. We have an acceptable starting point on our air temp sensor. Now we go out and we drive it. And with this, it's really nice with these older manual pot optimizers to be able to have this mounted in the passenger compartment so that it can be adjusted while driving. You breathe on the throttle, back off, lean it out a half a turn. Breathe on the throttle, back off, lean it out a half a turn. And then each time you breathe on the throttle, the impression that was left by the last light acceleration is still fresh on your mind. Whereas if you breathe on the throttle, pull off to the side of the road, pop the hood, pull the emergency brake on, pull the four-ways on, get out, go open the hood, turn the knob, close the hood, get back in, and start accelerating again, is very, very difficult to tell if you're getting to that where it's just starting to lean out stage. It's done. It's been done a few times. We've got good results in the classes doing it that way. Just, it was a pain in the butt to do.
On that test drive, you'd be doing, you're like in overdrive, or you're in, like doing 30 miles an hour down, or not from a dead stop?
You want to be doing it in overdrive or 30 miles an hour from a dead stop? What works for you? Because I'll tell you right now, I don't know where you live. I don't know where your shop is. I don't know what for geography you have to work with. So the way you would tune where you work out of and the way I would tune where I work out of is probably going to be different. And if you're in a very industrialized area, that 30 miles an hour is going to have to do. And if you're like here, you'd be doing 30 miles an hour, you're going to get rear-ended out here. So at this point, you're going to be doing 55 when you do your testing. So that's going to vary. Just make it work for what you have to work with. Any other questions? Now I'm going to start throwing questions at you. Your scan gauge reads on the engine temperature 208 degrees. With the optimizer hooked up, an older one, no ammo box. You go out and you do your tuning. You lean it out, lean it out, lean it out, lean it out, and you got the thing to where it's like off. It won't go anymore, and you still never experienced a loss of power. You can't turn it anymore. You bring it back to the shop, you pop the cover off, you go into test pin 6, and you see that it's like 0.03 volts. The optimizer stops working anything below 0.06 volts. Anything below 0.06 volts and you have a zero output on the optimizer. Because if you look at this chart here, this top row says if we're below 0.05 volts, the optimizer's output is 0. So you cannot adjust that pot below 0.05 volts and get anything happening on the optimizer side. Turn the optimizer switch point up to at least 0.06 volts. But if you're not getting it lean enough to give you a drivability issue, then your parameters are not changed enough for the computer to accept that lean of a setting. It's telling you don't know what you're talking about, you're on drugs, you're fired, I'm about to ready to, trip an engine code, and I'm going to show you, buddy. So we've established we can't increase that temperature reading on the older optimizers. If it says 208, that's the highest we're going to get without really screwing things up. So now what do? I'm just fishing for ideas, so no matter how cockamamie it may sound, I'm trying to get you thinking. It's one thing to listen to me, but I want to get you thinking. Any ideas?
208 was CTS.
Yep, coolant.
What's that?
Why not increase the coolant temp sensor resistance so you can bring that?
Well, if we increase the resistance, the way I showed you, that 208 will turn into 207, 206, 204, and that's going to take our low lean limit and actually make it richer and richer before the computer says you're full of it. All right, there's a couple of ways to do this. One, why don't you take like a 5K ohm resistor and throw it across the air temp. because it can be 20 below zero outside. As long as your coolant sensor says it's 20 below zero inside that engine, you'll have enough fuel to get it started. Even if the air temperature sensor says it's 130 degrees Fahrenheit, air. That's not a good scenario, but the engine will still start. So if you throw like a 5 or 10 k ohm resistor across your air temp sensor, you know, you'll raise it up some. That may help out. Take it out and drive it again. Another circuit is building a manual map adjust. If you can solder, you can build a manual map adjust. You're going to need an LM317 adjustable voltage regulator. Going to need a 220 ohm resistor. Single throw double pole switch. A 1 k ohm multi-turn pot, and of course a board and a case. Let me know when you've got that written down. When I say a board, you can purchase just wafer board like this. Radio Shack sells them where it's already got a couple of the circuits half done up for you. You can get them like this where there's absolutely nothing. Everything has to be wired off the back. Most electronic supply shops have little project boards.
That switch, single pole, double throw, is your designation.
Or single.
What it is it's just click, click. And you got three things. If you click it this way, it connects these two. If you click it the other way, it connects these two. So what's that called?
Well, you got a single throw, double pole on the board, right?
Uh-huh.
Okay.
STDP.
What's that stand for?
Single throw double pole. That's a switch that's going to be drawn up like this. Where it either connects this way or it connects this way. So this is your input. If the switch is this way, then this is your output. If the switch is this way, then this is your output. Everyone got this written down? Yes. All right, now to draw up the circuit. Gosh, let's see how good my memory is. I built about 10 of these, but not recently. Nope, I can't remember how to do it. Give me 2 or 3 minutes. I'm going to go up to Jimmy's office and see.
Oh, what do you want up there? Want me to get some?
Yeah, the map adjust circuit schematic.
Oh, schematic? I don't know where to keep that.
I think I know where I put it, but
Okay.
just give me 2 or 3 minutes, guys.